Hi guys, welcome to my calculus video. This is again the extension of the power rule, but this is step 3. In the previous video we just discussed, if you check our website, you understand that we did extension of the power rule using step 1, using step 2, and this is step 3. Now step 3 provides that if you have an integrand of the form f of x raised to any value, and then attached to that function you have the derivative of that same function. That is, if this is a particular function, say 2x, and then attached to this 2x you get 2. Remember, if you differentiate this 2x you get 2 using the derivative rule. So now the rule says if you see such a function in that form, you can just rewrite your answer as the function raised to the power n plus 1, the same way as using the power rule. The integral of x to the power n dx equals x to the power n plus 1 or over n plus 1 plus c. It's just the same way of using the power rule. So if you see it in this form, remember now it should be in the form a function raised to any value, and then attached to that, mind you, the derivative at times will be before this function, at times the derivative will be after the function. So it doesn't matter where is the derivative. In fact, so long it is product, meaning the sign between there is multiplication, you can interchange their positions. So let's look at this problem. 2x times x squared plus 1 raised to the third power. Now if you look in here, this is the function called f of x. X squared plus 1, the derivative of x squared is 2x. The derivative of 1 is 0. So the derivative of the guy in here is this man outside. So it means this function, this is the derivative. So if we rewrite this thing, we can have it as x squared plus 1 raised to some 3, some n now. N here represents 3 times 2x dx. So 2x dx represents the derivative, and then this represents the function. So they said this now, your answer should just be f of x. Now what is the function? The function is x squared plus 1 raised to the power n. N is 3. 3 plus 1. All divided by the same 3 plus 1 plus some arbitrary constant c. So finally this can just be x squared plus 1 raised to the power 4 all over 4 plus some arbitrary constant c. That is your answer. Now I want you to hold this answer. Let's write this answer somewhere and take another approach. X squared plus 1 raised to the 4th power divided by 4 plus some arbitrary constant c. Now let's write that answer somewhere and use another approach. Let's look at another approach. How we can solve the same problem using another approach. Now, since we said that what is in here is the function, and this gave us the derivative, let's apply the algebraic U substitution. Algebraic U substitution. So we can say let U equals what is here? Use x squared plus 1. Because if we differentiate this U, we can get this 2x. So we say let U be equal to that thing that if we differentiate, we can get the derivative that is attached to it. So if we differentiate this side, you have du. You differentiate this side, you have 2x dx. So you hold this one, keep it. So anywhere I see dx, I can put, in fact, what can happen is that this 2x, we can attach it to this dx. Meaning if we rewrite this thing, just look on this side, please. The integral of, we can write this x squared plus 1 first. And then we rewrite this 2x dx We have not changed anything because remember it's multiplication. We have not changed anything. It's still the same. This time time this, it still remains the same. So anyway, we see 2x dx. Now we're going to put du. And where's where we see, remember this thing is raised to the third power. Where's where we see x squared plus 1, we'll put u. So this whole thing now leads us to u cubed times du. Very, very easy now to integrate. U cubed times du. The integral of u cubed times du. So let's integrate this. The integral of u to the power n. The integral of x to the power n. So you just have u to the power 3 plus 1 all over 3 plus 1 plus some arbitrary constant c. So what is u? What was u from the beginning? U was what is under here. S squared plus 1 and then 3 plus 1 now is 4 divided by 4 plus c. So compare this answer with this answer. The two of them are the same. So that's exactly how we apply the u substitution for a problem like this, and that's how we apply the formula for the same type of derivatives. So let's look at more problems. Let's look at more problems quickly. We finish with the first one. Let's move to the second one. Now this second problem, it is a trigonometric